you? Hector here from helpmegraduate.com. Now we're going to work on applications of derivatives, and these applications are going to be used in functions and graph as functions. Okay, so what we're going to do is find whether if a function is increasing or decreasing in value, whether it's growing or not growing in a certain range. Okay, and of course the first examples are going to be pretty much light, and then we will move on and have a higher difficulty as the videos progress on. Okay, remember that the first derivative is going to give me those spots where there's a change in something in the function. Okay, and as you can see, we have right here the example is y equals 1 minus 4x minus x squared. So you can pretty much tell that this is a quadratic graph, and this is, it's going to be a parabolic thing. By knowing that the constant going with the highest degree variable is minus 1, it's a negative sign, we pretty much have an idea that the chart is going to look a little bit like this. Now, if this is the axis, this is y, this is x, it's going to probably be somewhere around this area. Okay, its concativity, it's going to be pointing south because of the negative exponent. Now, what we don't know is where exactly the function, stops growing and then starts going south. Okay, so that's what we're going to find out with the derivative application. So let's do that, all right? So like I said before in the past video where I explained applications of derivatives in functions, what we're going to do is calculate y prime. First thing to do is calculate y prime, and y prime is going to be equal to, well, this is an easy one. Okay, it's a derivative of a subtraction of components. Derivative of 1 is 0. Derivative of minus 4x is minus 4. Derivative of minus x squared is minus 2x. Okay, I'm speeding up a little bit because by this level you probably are aware of these three derivatives are pretty much straightforward. Okay, so this is the function that we have. Okay, this is our y prime. This is our first step. Second, or now, we must find the problematic points. I call them problematic points because, I think it's funny to call them that way. It's just points where there's some kind of an issue with the first derivative, okay? And these points are going to be somewhere where, like, y prime is equal to 0, okay? This is like the first series of problematic points. In the next example, we're going to see that there are a couple of more that we have to mention, okay? So, the problematic points we find by making y prime equal to 0, okay? So y prime is going to be equal to 0, therefore, we're going to have 0 equal to minus 4 minus 2x, okay? And solving this is a pretty basic equation. Minus 4 goes on that side, 2 goes dividing, so we end up with x equals minus 2. Okay? So this is the problematic point. There's only one, as you can see, because the equation is a first degree equation, so it only has one solution. So this is it, minus 2. Okay, x equals minus 2. We know that there is something going on with this problem, okay, with this point. So what happens? If you go to the chart, all right, we know that x equals minus 2, which is here, all right, here, is going to be the point where likely there's going to be a change in the increase or decrease of the function, okay? We knew, and I'm going to make a parenthesis here for a second, from what we said before, that the chart is going to look a little bit like this, okay? Because it's a negative quadratic equation, okay? It's going to look a little bit like this. So, we know that the function increases value until this spot right here, where the first derivative is 0. And this point, f prime of x is 0. Okay, or y prime. You can call it f prime or y prime. Then the function starts decreasing, and it continues decreasing forever and ever. Okay? Now I ask you, what is this point? What are the coordinates of this point? If you said x minus 2, you are correct. X minus 2 is this point right here. This is the point where the first derivative is 0. This is the point where the first derivative is 0. It means the tangent line is flat. Okay? And this is the point where the function stops growing and starts decreasing. Okay? So we can explain that a little bit better the following way. I'm going to make a division right here. 1, 2, 3. Since we found x0 equals minus 2, how many intervals of increase and decrease are we going to have? Okay, we found only one point. So how many intervals of increase and decrease are we going to have? We're going to have 2. Okay, we have 2 intervals. The first one is minus infinite until minus 2, and then the second one is minus 2 to infinite. Okay? Now we have to find what happens to the function in these 2 intervals. Okay? And you saw it pretty much graphically, but we also have to write it analytically. Okay? So, to find what happens, or to find increase and decrease in those intervals, we just evaluate whatever point we can find in the intervals in the first derivative. Okay? We evaluate a random point from the intervals. Where do we evaluate them? In f prime of x. So, if f prime of x is minus 2x minus 4, let's pick a random point out of the first interval, okay? Give me a random point out of the first interval. Minus infinite, minus 2. Give me a random number that is inside this interval. Minus 4. Minus 4. What happens if I do f of minus 4? F prime of minus 4? Okay? The result doesn't matter. What matters is the sign, okay? But let's do it. Minus 4 times minus 2 is positive 8. Minus 4? 4. Positive. Okay? And doesn't matter what number I pick from this interval. Whatever number I pick that belongs to this interval, the sign of f prime of that value is always going to be positive, as long as the value is here. Now what happens if I pick a number from the second interval? Let's do f of 4. Well, let's do it in the other line, okay? If I do f prime of minus 4, then what am I going to end up with? Well, minus times minus is, 4. 4 times 2 is minus 8. Minus 4 minus 12. The value doesn't matter. What matters is the sign. Again? So, whatever value I pick that is inside this interval, the sign of f prime is always going to be negative. Okay? So we have positive here, and we have negative here. So that means the following. This quadratic function, within this interval is always growing. Okay? This function in this interval is always growing. Okay? When x0 is minus 2, or when x is minus 2, the function is flat. It's its first derivative equals 0. And then in the interval of -2 infinite, the function is always decreasing, okay? And that pretty much makes sense with what we found, okay? Because if we were to graph the chart, it would look like this, like we said before. Here would be -2, and the graph would look a little bit like this, okay? And in reality, you know, it makes sense. Until this point, the function is increasing its value, okay, increasing, and then here, the first derivative is 0, and then from -2 and on, it starts decreasing forever and ever, okay? First example, let's do second example in the next video, okay?